Okay, today we are starting our chapter 7, and chapter 7 is all about kind of transitioning into using these trig functions and looking at them algebraically instead of kind of graphically. So we're really going to be looking at replacement and what can we do to look at some different algebra ideas. So we're going to start with our goals for today. We're going to identify and use the reciprocal identities. We're going to identify and use Pythagorean identities and identify and use the opposite angle identities. And we're going to kind of talk about that. It'll come clear in a little bit, probably more the next video, the opposite angle identities. So you're going to get in class a note sheet that has all of these on there, except for the opposite angle identities. But what I need you to know, what I need you to look at is to really to know these reciprocal identities. Hopefully a lot of them are like, oh yeah, I know this. What we use over and over again is this idea right here, is that cosecant can be replaced with 1 over sine. That secant can be replaced with 1 over cosine. The others that we will be using over and over again is that tangent can be replaced with sine over cosine, that cotangent can be replaced with cosine over sine. Now those 4 alone are probably our mightiest, or has the most teeth. The other one that we're going to be using quite a bit is all 3 of these Pythagorean theorems. We're going to talk about that here in a minute. So where we get all of this? Let's kind of talk about, okay, when we're looking at these, I'm going to kind of get rid of some stuff here. We'll get to these in a minute. All right, sorry about that. All right, so let's talk about just where we use it. So usually we have our right triangle in our first quadrant here. Here's my theta. All right, so we know that the opposite side is our y. So if we had our axis here, our axis would be like this. This is basically our y, this is basically our x. Well, this is really our sine. We've kind of talked in our unit circle that this is our sine, and that this is our cosine, that sine is y and cosine is x. So hopefully it makes sense that when we're talking about cosecant, which is the hypotenuse over the opposite side, that it's going to be 1 over sine. That when we talk about secant, it's hypotenuse over adjacent sine, 1 over cosine. But what really kind of makes sense here is when you look at this and say, okay, what is tangent? All right, so when we're looking at this, tangent is really the opposite over the adjacent. Well, tangent is the sine opposite over the adjacent, cosine. All right, same idea. Cotangent is the reciprocal of that. So cotangent is the cosine over the sine. The other one that really makes sense here is the idea that sine squared plus cosine squared, the two sides. So we'll start here with sine squared, and usually that's just what we do. Sine squared plus cosine squared equals 1. It's the Pythagorean theorem using this triangle that one leg squared plus the other leg squared will always equal the hypotenuse squared. All right, and that's where this comes from. What you might want to write down, and I know this isn't in your notes here, is the idea that, well, sine squared then equals 1 minus cosine squared. So we manipulate this quite a bit. We talk about how cosine squared equals 1 minus sine squared. This is just good reference to have, and that we're going to be coming back to over and over again. So these are again our commonly used ones more than any of the others. These are used as well, but I don't think has to be memorized. What I have circled in red really should be memorized. So let's look at, okay, how are we going to use this? So the idea of, okay, using a reciprocal, excuse me here, tell me what is the cosine, if the cosine of some value is 2/3, find the secant of that same angle. And it used to be, oh, we draw a picture and we'd be like, okay, let me look at the picture. Well, now we can use some of our knowledge. What we know algebraically is that secant is equal to 1 divided by my cosine. So if I'm trying to find the secant of this angle, it's going to be 1 over 2/3, 1 divided by 2/3. Well, secant then would equal 2 over 3, or 3 over 2, excuse me, the reciprocal. So 1 divided by 2/3, sorry, is 3/2. So, a lot of you probably could have told me that just on your own. Same idea, cotangent and tangent here. Cotangent, the tangent just takes the reciprocal. So some of you might even need to write this down. You might be able to say, oh, well, if I'm given the cotangent, the tangent is simply the reciprocal. So the tangent of this would just simply be 2 over the square root of 5. I don't know why I wrote 2. Sorry about that. 5. Okay, so we have our tangent and cotangent. Okay, well, let's move on here. Now, we have a sine and we want to find cosine. Not as easy just to go, okay, it's a reciprocal. It's not like that. But they do have this algebraic connection. What we know is we know that sine squared plus cosine squared equals 1. Well, sine squared is replaceable with 1/5 in this case. 1/5 squared plus whatever the cosine squared equals 1. We have only one unknown here. So 1/5 squared is 1 over 25 plus cosine squared equals 1. I'm going to kind of move over here. Subtract 1/25 from both sides. So cosine squared equals 1 minus 1/25 because we took away 1/25 from both sides. Well, that equals 24/25 is what my cosine squared equals. And here what I need to do is just take the square root of both sides. And so now my cosine would equal the square root of 24 over 5, because the square root of 25 is 5. You could have gotten to the same answer by saying, okay, we're in the third quadrant. Draw on your angle. We did these already. We said sine, and then we calculated our missing side. We could have gotten that same answer in another method, very much graphically. This is about how do we get to it algebraically using the formulas that we know. Another formula that we've worked with is this idea that tangent squared plus 1 equals secant squared. Okay? Knowing this, my tangent 4/7 squared, add 1 to it, is going to equal my secant squared. Well, 4/7 squared is 16 over 49. All right, I have to add 1 to that, equals secant squared. Well, instead of 1, let's change this 1 here, and let's change that to be 49 over 49, which is just genius, because 49 over 49 is essentially 1. All right, it's the same value over itself. Now we can add the two together and say really we have 65 over 49 equals secant squared. Now again, what we're doing to both sides is taking the square root of both sides to say I want to know what secant alone is. So my secant of my theta here would equal the square. Go ahead and just leave this as a square root of 65 over 7. That's my final answer here. Okay? So you kind of get an idea of kind of how we work these out. Another type of problem says, okay, how do we express each value as a trig function? And the big question here is in quadrant 1. How do we show it in quadrant 1? Well, first you have to decide, do I have more than a rotation here? Am I going around completely and then coming back? So maybe the terminal side is already in quadrant 1. And so for this first one, cosine of 7 pi over 3, the terminal side is already in quadrant 1. And what I would do is I really want to go like this, and I want to kind of unrevolutionize it, or take a revolution away. A revolution, if you remember, is 2 pi radians. So I need to take away a revolution. Well, 7 pi over 3, I could take away 6 pi over 3. Because that's what 2 pi equals. These two are equivalent to each other. So really my answer here would be that it's the same idea as taking the cosine of pi over 3. Now, that is what it's asking. It's saying express it as a trig function. This same trig function, cosine of pi over 3, is the same thing as the cosine of 7 pi over 3, all right, because of the revolution. Same idea here with the cosecant of this negative 330. I can add a revolution to it. All right, and again, I can take away a revolution, I can add a revolution. I'm not taking or changing the value. It still has the same terminal side. So that means that that equals the cosecant here of 30 degrees. And I can leave it like that. That's in my first quadrant, I'm fine. I need to get another problem here. So now I'm looking at the sine here of 390. Well, again, I can take away, in this case, I'm going to just take away a rotation, 390 minus 360. So again, I just happen to be in my first quadrant there. In cosecant of 10/3. All right, here, oh, sorry, 10/3 pi. I didn't have that right. All right, we need to take away cosecant 10/3 pi. Let's take away 2 pi. Take away a rotation. 2 pi, I'm just going to replace it with 6 pi over 3. So take away. What I have for an answer is we're talking about the cosecant of 4 pi over 3. Now you have to get kind of a visual and decide what you're talking about. That's like 1 1/3 pi. 1 pi would be at 180 degrees. That third pi, you know, if I'm just kind of having a visual in my head, that's what my third pi is going to look like. That's what my third, like pi over 3, it's like pi and then plus pi over 3. That's what 4/3 pi is. So I'm actually in the third quadrant, but it said I need to show this in my first quadrant. Okay, first quadrant. Well, it's a lot like cosecant of pi over 3 in my first quadrant. It's saying like, okay, my reference angle would be pi over 3. But what you have to say here is cosecant goes with sine. And in sine here, this sine is negative here in the third quadrant. So my answer in the first quadrant has to be negative. So it's the negative of whatever the cosecant of pi over 3 is. So it's important. That's what we kind of were talking about when we had those negative values. And I know a lot of you are going, well, wait a minute. How do I remember where things are positive and negative? If you remember, we had this. All students take calculus, where all were negative here. That sine was positive in the second quadrant, which would mean that cosecant is also positive. Tangent is positive in the third quadrant, which means cotangent also positive. Cosine was positive in my fourth quadrant, which would mean secant also positive, and that's going to be important to remember and remind yourself. The last concept, the type of question that we have from this type of problem, excuse me, is here where we're simplifying. My biggest hint, put everything in terms of sine and cosine. So with my first problem, we really have here cosine divided by cotangent. That's what we're talking about. And what I want you to do is put everything in terms of cosine and sine. All right, this is already in terms of cosine and sine. And we're dividing by cotangent, and I'm going to write that as cosine over sine. Well, in order to divide by a fraction, we need to multiply by the reciprocal of what I'm dividing by. So I'm going to change it to cosine over 1 times sine over cosine. Now it might occur to you that, hey, that's kind of slick because I can reduce my cosines. And so in the end, I had left sine. So I kind of don't mess with the thetas while I'm working these out. I just leave it at the end and I throw in the end the theta in the end as well. So let's do another one. Now we had cosecant times cosine times tangent. Well, cosecant I can write as 1 over sine. Cosine, I already have it in terms of sine over cosine. I'm going to leave it there. Tangent is sine over cosine. Now we just go back through and say, where can we reduce? Hey, my sines reduce, my cosines reduce. In the end, my answer is simply 1. And I know I'm rushing it here, but I want to get to this last question here. So here I have cosine, cotangent, and I'm adding sine. All right, well, cosine I leave as cosine over 1. Cotangent is cosine over sine. And then I'm adding sine. I leave it as sine over 1. Okay, so now I need to get a common denominator in order to add these together. One of the things I could do over here to make a common denominator is if this had a sine in the denominator, then I'd have matching denominators. But what I need to do is I can only multiply by a 1. So to multiply by 1, I just multiply by sine over sine. So what I get here is cosine squared over sine. I'm adding it to sine squared over sine. So what I get is cosine squared plus sine squared all over sine. Well, if you remember, cosine squared plus sine squared can be replaced with a 1. So now I have 1 over sine. And if you remember, 1 over sine can be replaced with cosecant. So my answer in the end was simply cosecant. Your assignment for this these problems is to take page 427, 8 through 16. We did a lot of them in class. 25 through 35 odd, and 38, 41, 49. And there's the rest of the assignment. Good luck.